Bismillahirrahmanirrahim. Today is our lecture number 13, and today we will start our second chapter about differentiation. And our today's topic is average rate of change and instantaneous rate of change. Now, what is average rate of change? As we know very well that whenever we are going to find the distance between any 2 points, here we have the 2 points. Let's say this is your point A and the value at this point is your f of A, and this is your point B, and here we have the value of the at this point we have f of B. And when we are going to find the distance between these 2 points, we draw a second line. This is a second line is defined as the line between any 2 points on any curve is a second line. And if we find the distance between these 2 points, the or formula will becomes equals to f of b minus f of a divided by b minus a, or in other words you can say it like now average. I will explain it further. Average rate of change, average rate of change. Let's say we have this graph and we have this curve. Here you have your first point, that is A, and here you have your second point, that is B. And the value at this point along with y-axis you have f of A, and B on y-axis you have f of B. And you have to find the distance between these 2 points. So what you will do, if you draw a line between these 2 points, this is not a straight line, so I will try it again. Okay, this is a second line. This line is known as second line. And what are you going to do here? You are going to find the distance between these 2 points. And in physics and in mathematics, maybe you have some idea about slope. And whenever we find the slope, what we will do, we have this type of y2 minus y1 divided by x2 minus x1. This is the formula for slope. This is the same concept, but here we are using the function also. So whenever we are going to find the average rate of change, the formula will become equals to f of b minus f of a. Look at here, this is y2. Here you have 2 points, B and f of B. And here you have 2 points, and these points are A and f of A. This is the point on x-axis, and f of A is a point on y-axis. And here you have, at x-axis you have a point B, and at y-axis you have a point f of B. So the distance between these 2 points along y-axis divided by the distance the difference between the points at y-axis, f of b minus f of a. And in other words, we can say it is a change along y, and this is the change along x. This difference shows the change along y-axis. This delta represents the change from greater point to lesser point, and this delta x represents the difference between x2 minus x1, or in other words b minus A. So average rate of change, its formula becomes equals to f of b minus f of a divided by b minus a. And here you have this curve, and these are the 2 points, and you are going to find the average rate of change between these 2 points. And whenever you are going to find, actually it's the average rate of change. When you find the distance, the average rate through this formula, actually you are going to find not it is exactly gives you the same value or at this curve is moving, but average rate you can measure through this formula by using this second method, second line. By using this second line method, you can calculate average rate of change. Here you have the definition of second line and tangent line, because we have used so many times these two definitions. So I would like to give you a simple concept about these two lines, and I want to show you the difference between these two lines. Second line is a line that intersect two or more than 2 points on a curve. Look at here, I am saying this line is a second line, and it is the difference between 2 points. Here we are using the concept of difference between two lines. And the tangent line in geometry, the tangent line, or simply when we call it a tangent to any curve at a given point, is a straight line that just touches the curve at that point. Now, this graph shows the difference between second line and tangent line. This red line represents the second line and you can see very clearly here you have 2 points. This is the curve, and the second line is showing the difference between the 2 points. This one is the first point, and this is your second point. But the tangent line, which is the tangent line is represented by here by this black line, and you can see this line just touches the graph at touches the curve at just single point. And what's the difference between, why I'm telling you the difference between second line and tangent line? Because when we calculate the average rate of change, we use the concept of second line. But when we use the concept of instantaneous rate of change, this is also a concept through which we can calculate the change in curve, and that is known as the instantaneous rate of change. And in this instantaneous rate of change, we use the concept of tangent line. And what is the definition of this instantaneous rate of change? The instantaneous rate of change of f with respect to x at a, that is any point, is the derivative, in which we can say derivative means you can here you can say that derivative is a term which we use when we are going to calculate the change of one variable with respect to another variable. I will explain it further when we will start this chapter. Furthermore, the derivative, this prime represent the derivative. F prime of a is equals to limit h approaches to 0, f of a plus h minus f of a divided by h, provide the limits exist. Simply, you just keep one thing in your mind, that differentiation formula is used when we are going to use the concept of this tangent line. When we calculate or instantaneous change at single point, we say that we'd say that the rate of change is instantaneous. Now, difference between average rate of change and instantaneous rate of change. average rate of change. Slope of second line, use slope formula, which is the formula which I have shown here. A of x is equals to f of b minus f of a divided by b minus a. But in instantaneous rate of change, slope of tangent line, use derivative. You can see this is the tangent line. Okay, I will explain it furthermore. When I talk about the average rate of change, means suppose this particle is moving in a straight line and its position from a fixed point. I will draw another graph. I will give you some example, I think, which will explain you. S of t, let's say S of t is equals to S of t is equals to t square minus t. Okay. Now, this is simply a function of s, and we know that which one is a independent variable and which one is dependent variable, right? Now, if you have an interval, let's say t is equals to 3 seconds to t is equals to 5 seconds. These are two different time is given. Now I will explain it. If we say that, suppose we have a particle which is moving in a straight line and its position after times t and t1. Let's say we have a particle which is moving from this point to this point, and after time t and t1, after time t and t1 are given by s of t and s of t1, means when it is at point t, its value become s of t, and when it goes to t1, let's say this is your t1, its value is equals to s of t1, right? Now, if then the distance travel in time t1 minus t, the distance travel from t1 minus t, where you know that t1 is greater than this t, is s of t1 minus s of t, or in other words we can say that this is equals to s of t1 minus s of t divided by t1 minus t. This is the difference quotient. This is the difference quotient which we are going to use. And this also represents the average rate of change of distance over the time t1 minus t. If t1 minus t is not small, it is not a small difference, difference of time, then the average rate does not represent the accurate change. near to t. So we elaborate the idea by moving a particle in a straight line whose position in meters after t second. Means I'm going to means I mean to say that if the difference between these times is very small, then I cannot explain you the concept. But if between these time limits from t to t1 the distance is large, means its distance is not a small, then we can means its distance in meters, then we can easily give you the idea that how the average rate of change behaves in such conditions. So if I take t is equals to 3 second to t is equals to 5 seconds, what happened? We are going to calculate the average. We are going to calculate the average rate of change. So if we use the formula average rate of change, average rate of change average rate of change Achha, now average rate of change is equals to, we are going to use this formula s of t1 minus s of t divided by t1 minus t. So s of t is s of t. How we calculate this s of t1? T1 means this first time. This is your t and this is your t1. Now we have to calculate this. This is our function. So first we will calculate s of t1, then s of t. So when since s of t is equals to t square minus t, and when t is equals to 3 second, s of t is equals to 3 square minus 3, 9 minus 3 is 6. And this is, here we have t square plus t. So 3 square plus 3, 9 plus 3, 9 plus 3 is equals to, it's not 6, here you have 12. And then for second time, when t is 5 second, again use this formula s of t is equals to 5 square plus 5 is equals to 25 plus 5, it's equals to 30. And when you find average rate of change, average rate of change, it is equals to s of t1. This is your s of t1, this 30. 30 minus 12 divided by 5 minus 2. T1 is your this 5 second and T is your 3 second. So 5 minus 3 is equals to 30 minus 12 divided by 2, 10 minus 2, 8, and 18 divided by 2 is equals to 9. So by using this method, you can calculate the average rate of change. In your book at page number 42, there you can see. Kindly open your book, pause this video and open your books and see at page number 42. Here we have a table in which different examples are given to calculate average rate of change, and you can see here I have solved first example for you, and you can see easily the second example, which is example number 2, example 2, in which you can see that t is equals to 2 seconds and t is equals to 4. You have to calculate average rate of change from t is equals to 2 seconds to t is equals to 4 seconds, right? And the third example is t is equals to 3 seconds to t is equals to 3.5 seconds, right? You can calculate it by using the same formula, that is for both examples you are going to use this formula for calculating average rate of change. Now this example is these all three examples for large distance, but if now we are moving, this is the average rate of change when the distance is large, when the distance is measurable in some big quantity, and that's why it is a clear concept in which we can see the distance between any 2 points. But now we are moving from average rate of change to instantaneous rate of change, in which the average rate of change approximate to approximate to actual speed of the particle after any seconds, or here in your book there are after 3 seconds, and the table which I'm going to construct for you, that is by taking the small intervals in the second table, in the second concept, which is the instantaneous rate of change. I'm going to construct a table by taking small intervals. In the previous these three examples, the intervals are for the big values, big intervals. Okay. Now, example 2. Here we have intervals. Interval is t is equals to 3 seconds to t is equals to 3.1 seconds. Now you can see the first point is the first time interval is 3 and the second time is 3.1, means the difference between these two times are just 0.1. Now when we calculate the average rate of change, by using the same formula, what happened? 3.1 square plus 3.1, just wait, 3.1 square plus 3.1 minus 12 divided by 3.1 minus 3 is equals to when we calculate 3.1 square plus this whole fraction give you 12.71 minus 12 divided by 0.1, and that is 0.71 divided by 0.1, and it is equals to 7.1. Now this is the first interval 3 and the second one is 3.1, and we have calculated this time. Actually in this case we are using this formula, means S of t plus delta t. This is the actual time and this is a small difference of time minus S of t divided by delta t. The same thing you can see here. The previous formula is I will write here the formula in comparison over here. The previous formula was S of t 1 minus S of t divided by t1 minus t. These are the two different formulas. This formula which we have used is for average rate of change, and this formula is for instantaneous rate of change. And what's the difference between? The difference is we are calculated here a difference, a small change in our second time, a small change of this time from t to from 3 to 3.1, and here the same thing happened, right? And you can calculate these calculations separately also, but if you are doing this thing like as I have done on this table, so both are correct. So it's up to you which method you are going to apply. So this is the end of today's lecture, which is very short because of the concept of these two things are the new concept for you, and you just focus on these things, and if you have any problem you can contact me on my WhatsApp number. So this is the last thing, instantaneous rate of change. What is instantaneous rate of change? We need to shift our thinking from average rate of change to instantaneous rate of change. And average rate of change is calculated over an interval, whereas instantaneous rate of change is found on a particular point. Like when I will start the derivative of the function, I will explain you further the instantaneous rate of change, which is the main concept which are used in actually finding the derivative of any function. So don't confuse in these two concepts. These are the basics of your derivative. The actual topic we will start in our next lecture, inshallah. So it's the end of our today's lecture. This is the question for you. A car is traveling on a 75-mile trip for 3 hours. What is the average rate of change? And what is the instantaneous rate of change at t is equals to 2? Thank you very much.